Hi class, I wanted to provide a video this week going over a couple of the problems that might give you some issues and help you out. So the very first one that I wanted to go over was number 1. We had Barb Hotchins is in the 28% tax bracket. A tax-exempt employee benefit with a value of $500 would have a tax equivalent value of approximately what? So to answer this question, you need to take the benefit value, which in this case was $500, and then to get the tax equivalent value of what it would be valuable to would be 1 minus the tax rate. So $500 tax exempt benefit would have the equivalent value of a taxable benefit of what? So we take benefit value, 1 minus the tax rate, says that she is in the 28% tax bracket. So we take 500, the benefit value that's not taxable, to compare it to the taxable value. We kind of put it in this formula to kind of see what it would look like if it was taxed. And then it would be 1 minus 0.28, which is just the 28% tax bracket turned into a decimal form. So 1.0 minus 0.28 is 0.72. So 500 divided by 0.72 will give you your answer. The second one that I wanted to go over is number 2, and that is Caroline lives in City A and earns $50,000 per year. The cost of living of the living index in City A is 0.8. She is considering a move to City B, which has a cost of living index of 0.9. How large a salary will she require in City B to maintain her current standard of living? So this is how we set it up. We go $50,000 is what she makes right now, and she's living in a city with a 0.8 index. She wants to move to a city with a 0.9 index, and we need to know how much. So this is a ratio to ratio. She lives in a city making $50,000 with a 0.8 index. She wants to move to City B, which we don't know how much she needs to make to live at a 0.9 index. So we cross multiply 50,000 times 0.09, and that gives us our 45,000, and it's over 8. So if we cross multiply this, not 0.9 times 50,000, we get 45,000 divided by 0.8, and that should deliver us to our answer of what it should be to live in City B at the 0.9 index. The next one I wanted to go over was problem 11, and that's determining the future value of education. So Jenny Franklin estimates that as a result of completing her master's degree, she will earn $7,000 more a year for the next 40 years. So we have 2 parts to this. We have what would be the total amount of these additional earnings, and that is just $7,000 times 40 years. It's quite simple. And part B is a little more complex, and it talks about using a table in the chapter 1 appendix, which I don't believe we have in this textbook. We had in the previous textbook, but I've provided a link for the same table. So what would be the future value of these additional earnings based on an annual interest rate of 6%? So what would the value of those be if she took that extra earnings and deposited into an interest-bearing account making 6% interest for 40 years? So $7,000 for 40 years at 6%. So if you click on this link or go to this link, I've provided it in the announcements, it will, just a minute, and I will bring it up. It'll take you to, let me move this so you guys can see it. It'll take you to this website, and it gives you the future value of ordinary annuity tables, and we have the periods along the side and the percentages along the top. So this was a period of 40 years at 6%. So we have to find the 6%, and then the period's actually on the second page or on the right-hand side. So we take 6%, which is the third column over, and we take it down to 40 periods, and we intersect 6% and 40. We get 154.762. Now we can take that, and I move my screen back again. we can take that $7,000 and multiply it by that 154.76 number, and we will end up at, that will give us, instead of doing a whole bunch of math, that actually just skips right to the end and gives us our answer. So you just go to this chart or the link that's provided in the announcement, intersect 40 years and 6%, gives you a factor or a number. Take that number and multiply it by 7,000, and that will give you what putting $7,000 in an account for 40 years at 6% interest will give you the answers to. So for 12, we have comparing living costs. Brad Edwards is earning $45,000 a year in a city located in the Midwest. He's interviewing for a position in a city with a cost of living of 12% higher than where he currently lives. What is the minimum salary Brad would need at his new job to maintain the same standard of living? So we need to think about this for a minute. Right now, $45,000 is what he makes. That's 100% of what he makes. He is moving to a place where he needs 100% of his current salary plus 12% more just to stay where he's at right now. So how much does he need to be comparable to his current job? He needs 100% of his $45,000 plus another 12%. So 112% of 45,000, or you could lay it out like 45,000 times 1.12, which is 112% put in decimal form. For 13, we've got calculating a future value of a salary. During a job interview, Pam Thompson is offered a salary of $28,000. The company gives annual raises of 4%. What would Pam's salary during her 5th year on the job be? So I've had students before get a little confused on this one when they gave her 5 years of salary. But the first year, she's going to make $28,000. Then the next year, she's going to get a raise of 4%. So we start at $28,000 for the first year, and then we actually add 4 years of salary increases. So you can do it the old math way, or the long math way, where we take $28,000 times 100% of her current salary plus another 4%, or 104% of her salary each year, or convert it to a decimal 1.04. So at the end of her second year, she'd be making $29,102, or 120. And then we'd take that and we'd add another 4%. We can do that through year 5. That's one way. Or we can skip to the end a little faster, and we can use the future value tables. Again, the link's in the announcements. On that future value table, we intersect 4 years and 4%, and it gives us a factor that we multiply by 28,000, and that will give us our answer as well. For 14, we have another future value one. And again, the link is in the announcements. Calculate the future value of a retirement account in which you deposit $2,000 a year for 30 years with an annual interest rate of 6%. So you could do this longhand and do it for 30 years. It would take you a while. Each year you'd have to add $2,000 and then compound to a 6% interest, and then add another $2,000 the next year and compound to a 6% interest. So it would take you a while. Or you can go to the future value of an annuity, which an annuity just means an annual payment, which in this case is $2,000, and you intersect 30 periods and 6%. That's going to give you a figure that you'll multiply by 2,000, and that is your answer. For 15, we have comparing taxes for employee benefits. Which of the following employee benefits has the greater value? Use the given formula in the financial planning calculations box. Again, this is referring to the old text, so I wanted to provide you the formulas. The formula is, I don't know that it's even that helpful, so I'll just walk you through it. It's more common sense. So a non-taxable pension contribution of $4,300, or the use of a company car with a taxable value of $6,325. So which is more valuable? So we have non-taxable, $4,300. That's what you get. Or we have a taxable benefit worth $6,325. But we have a 28% tax rate. So 28% of taxes is going to go straight to the government. You're not going to get it. So at the end of the day, after you pay your taxes of $1,771 on that $6,325, you will only pocket $4,554. But in this case, compare that to your non-taxable benefit, it's still more, just not as much more as you thought originally. So the taxable benefit of the company car use would be more valuable for A. For B, a life insurance policy with a taxable value of $450 or a non-taxable increase in health insurance coverage valued at $340. So we've got a taxable life insurance policy of $450, so 28% goes to the government, so $126 goes to the government. That leaves you with $324. Or non-taxable health insurance coverage of $340. Well, in this instance, the non-taxable benefit is more valuable. And then the very last problem is comparing employment offers, Bill Mason is considering two job offers. Job 1 pays a salary of $36,500 with $4,500 of non-taxable employee benefits. Job 2 pays a salary of $34,700 and $6,120 of non-taxable benefits. Which position would have the higher monetary value? Use a 28% tax rate. Now, I've always thought that this problem was flawed in the way they worded it because both benefits are non-taxable, so you don't even have to figure the 28% tax rate. You could figure out, just like we did in problem 1, what the taxable equivalent value was by taking the benefit and dividing it by 1 minus the tax rate. But if you're just comparing apples to apples here, a non-taxable versus a non-taxable, it's comparable, so you don't need to figure out which one had a higher monetary value. You're comparing non-taxable to non-taxable. Now, if one had a taxable and the other had a non, you would need to make the conversion to be able to compare it. But in this case, they're very comparable. So it would be job 1 plus the non-taxable benefits, job 2 plus the non-taxable benefits. Which one is the better deal?